Hi, hello. My name is R. Sri Charan and my roll number is 5D1. I am from CHC section. And today, my topic is underwater depth estimation and image restoration based on single images. An increasing number of real-world applications are related to underwater environments, including fissures, environmental and structural monitoring and inspections, and oil and gas exploration. Petroleum and natural gas are still the most important energy source in the world, and researchers have recently discovered relevant oil and gas reserves along the coast of Brazil and African underneath what is known as pre-salt rock formation. Pre-salt layer of rock in the earth crust consists of pre-filled salt converting large areas on the ocean floor. Recent findings have unveiled that over millions of years large amount of organic matter have been de- deposited beneath the layer of preceded salt between the west coast of Africa and the eastern shores of South America. This organic matters has been transferred into oil that in many areas it influenced the gas. In Brazil, the pre-salt area spans a range of about 800 kilometers along the coast. Geological have estimated that the oil and gas reserves in that area are on the order of 80 billions, which would place Brazil as the sixth largest holder of reserves in the world behind Arabia, Iran. Previous works have approached the problem of restoring images acquired in underwater scenes from several prescripts, such as using special purpose hardware, stereo image, and polarization filter. One, although the improvement achieved by these approaches, they still present several limitations. For instance, methods that rely on specialized hardware are expensive and complex. The use of polarizers, for example, requires moving parts, and it is hard to implement in automatic validation tasks. In a Serovision, system approaches the correspondence problem becomes even harder because of the strong effects imposed by the medium methods based on multiple images require at least two images of the same scene taken under different environment conditions, which makes them inconvenient for real-time applications. Thus, the problem of image restoration for underwater scenes still demands much research in spite of the advances that have already been attempted. Visual computing and the process of deploying countries, light source absorption, forward rating, direct light image. Figure the underwater attenuation light model. The dashed lines shows the forward scattering and back scattering effects. The scattering of light rays at small and large its thus affects respectively. Direct light is the opposition of light irradiated by the skin that reaches the image plane. This is the process of scanning the image. So, Underwater attenuation light model. The, the formation of underwater image results from a complex interaction between the light, the medium, and the scene. Of simplified analysis of the interaction is possible while still maintaining physical feasibility. To this end, first order effects are forward scattering and backward scattering. That is the scattering of light rays at small and large angles. The absorption of light is associated with these two effects because they respond to contrast degradation and color shift in image. Illustrate this effect. And second one, dark channel prior. The DCP is a statistical prior based on the observation that natural outdoor images on a clear day exhibit mostly dark intensities in a square patch of the image. One was inspired by the well-known dark object subtraction method from the remote. E and his colleagues considered that in most of the non-sky patches images of outdoor scenes, at least one color channel in the RGB representation would have some pixels with an intensity that was almost zero. This low intensity in the dark channel is due to three factors: shadows in the image, colorful objects, or surfaces where at least one color has two intensity, and dark objects or surfaces. They collected a large number of outdoor images and built histograms, and with those, they showed that about 75% of the pixels in the dark channels had zero values, and that the intensity of 90% of the pixels falls below 25 on the scale of the 0 to 255. Those results provide strong support for the DCP assumption for outdoor images. This period lets us estimate an approximation of the amount of the medium transmission in local patches. E and his colleges showed that DCP provided execution resulted in assistance. The use of local patch affects the performance of the median transmission estimation. He and his colleagues proposed the use of spectral mating method to verify the estimated transition. Their method presents good result, but it requires a high computational effect to process the matrix. Other works proposed approximate solution to make it faster by using Markov random field or filtering techniques such as DCP for underwater image and their variations. Because of the good result obtained by the DCP method for hazy scenes and the similarities in the modeling of hazy and underwater images, some previous works applied DCP to process underwater images. Luchu and Wang were some of the first researchers to use DCP for underwater image. For their reported results show a limited number of experiments where the visual quality of the result does not present a significant improvement even for images with small degradation. John Ching and Yang Chinch also proposed an underwater image restoration method using DC. Their method obtained good results for real underwater images, but it was limited by the DCP method in underwater images by the assumption that the image is predominantly blue. Recently, Srikava and Vinitlo proposed a variation of DCP that filters the medium transmission by using a joint filter. The improvement attained in the image restoration when compared with standard DCP, the limitation related to the red channel remains same. Figure 6. Restored images and depth estimation. A underwater image with the region where the backscattering consists was estimated using UDCP. DCP red patch, MDCP yellow patch, and BP purple patch. Restored images using BUDCP, DCP, EMDCP, and FPP colorized depth maps obtained using CP, DCP, MDCP, and BP original image. Given. Thank you for giving this great opportunity to explain one topic in front of you.